All right, we're going to go ahead and get started here. So welcome, everybody. We're here on behalf of Allstate to present you guys SEDATED. Quick introductions. I'm Simeon Cloutier. I'm the project lead on the SEDATED project. I'm also a lead application security engineer at Allstate. Joined by my colleague, Dennis Kennedy. He's the lead developer on the SEDATED project, and he's also an application security engineer at Allstate. Quick agenda for what we're going to talk about today. First, we'll go through the problem statement. We'll talk a little bit about the whys. Why are we talking about this? What is the problem statement? We'll go into the solution. We'll do some demos. We'll show you some source code, go through some of the processes that we coupled the source code with. Then we're going to get a little bit into performance and future goals, and then talk about open sourcing. Okay, so I wanted to start with OWASP Top 10. Hopefully everybody's heard of that. Number 3 in particular, sensitive data exposure. So this is when your application deals with sensitive data like PII, PHI, PCI data, or anything that you consider within your company to be sensitive data, restricted, confidential data, anything like that. So it's on the list because you should be protecting it properly. Whether it be in transit, when you're transmitting it across the line, you should be doing it securely. Or when you're storing it, you should be storing it securely, and you should have proper access control mechanisms in place for that data. So it's number 3 on the list. It's important, and we're going to tie this together. Why are we talking about this and our solution to address some of the problem statement? So I want to talk real quick about a company, 2 exploits that they had. So May 2014, this company had an exploit where they had 50,000 driver's license data leaked. And then in October 2016, unfortunately, they had 57 million users' data leaked and 600,000 driver's license data. Does anybody know what company this is by chance? Anybody besides Joe in the back? Who is it, Joe? It's Uber. So this is Uber. So we're not here to pick on Uber or rolling this together. We're trying to secure our data, right? But we wanted to talk about the particulars of what actually happened in both of these exploits. And this leads right into the problem statement that we wanted to talk about today. So how exactly did this happen? So in May 2014, their database key, unfortunately, was on a publicly accessible GitHub page. The hacker got hold of it, found it, and in they go. So that's how they access the data. And then in 2016, again, it was a database key. They had the database key, but this time it was inside of a private repository. But the hacker was able to gain access to that repo, and once they gained access to that repo, there was the key sitting in their repo. So we want to talk about this in particular. This was this is a database key. This is like the master, key to your kingdom, right, or your data. It's sensitive data, and you want to have defense in depth. You want to have multiple layers that an attacker has to jump through to gain access. So with sensitive data like this, we definitely would recommend keep it out of your repo. Things like database keys, private keys, passwords, anything like that. Store it somewhere else. In this instance, maybe on the server that the app's running on, maybe you have an environment variable where this key is sitting, or somewhere else, but not in the source code. So this leads into our problem statement that we wanted to talk to you about today. How do we prevent sensitive data from being stored in Git? So data like this, or passwords, or digital certificates, things like that. How do we prevent that from being stored in Git? So the solution that we're here today to present is SEDATED. So SEDATED stands for Sensitive Enterprise Data Analyzer to Eliminate Disclosure. I want to talk about the flow of SEDATED. How does SEDATED work? What exactly does it do? So in this diagram here on the left-hand side, you have a developer, and on the right-hand side, you have your Git server. In this example, this is GitHub Enterprise. This could be GitLab, or this could just be a Git server that's running. So the developer's coding their code, right? They're constantly coding and pushing things to their repository. So in this example, the developer codes something, it follows the yellow arrow, pushes new code. Instead of it going straight into the repository, it's going to hit SEDATED, the black box. Now, if you're already familiar with this, it's a pre-receive hook running on the Git instance. So technically, that's what SEDATED is. It's a pre-receive hook. So what it's going to do is it's going to fire before it goes to the repository. And it's going to scan all the deltas. So whatever code the developer is pushing, it's going to scan that. And it's going to see if there's sensitive data in there. If there is no sensitive data, it'll follow the green arrow and it'll get pushed into the repository. That's happy path, right? But if it does identify sensitive data in this push, it'll forcibly reject it. That's going to follow the red arrow. And that code with that sensitive data will not end up in the repository. And again, that's the problem statement that we're after today with this solution. With that, I'll pass it over to Des.
Sweet. Thanks, Simeon.
Can I ask a quick question for you?
Yeah.
It's pretty easy to get around Git hooks.
The,
You can force sometimes to not do the hooks.
this,
You can force this.
Not that I'm aware of.
it's a pre-receive hook, so it sits in the server. So,
It's on the server side, it forcibly runs against
Okay.
all pushes.
yeah. All right, and let's take a look at our demo here. Okay, so what we're gonna do, this is a pretty empty repo, our demo repo, we just got a README in it. We've got a clean working tree, and what we're gonna do is we're just gonna create a simple file, just hello world Python file, and you can see it over in the our text editor over there. Jump over there and we'll just throw some code in. We'll do just a print, simple print statement, hello world. So this is going to be this is a happy path. So this is no sensitive data. If you've got SEDATED turned on your repo, and this is what's going to happen. So you're going to do your git add, and then you're going to do your git commit. An important note is the SEDATED won't fire on this git commit. So it's not going to fire here. This is just creating the commit ID. And once we do that, now we've got the commit ID. And now is when SEDATED is going to fire when we do the git push. So we're going to do the push right there. And then once we try to push, this is where SEDATED is going to scan for deltas for any sensitive data. And if there's no sensitive data, you get this happy credential panda right there. So it's pretty clear, and you can see on the bottom, push was accepted. So this was a happy path. So everything's good to go. So on this one here, we've got the sad path here. This one is the sad path. Okay. So on this one, we're going to actually add a hard-coded credential in it, and we'll see what happens. So we'll add a creds.config file, create it. We'll jump back there. We will add just a hard-coded password. We're going to say our password is my password. 1, 2, 3. Yep, we're saved, jump back into the terminal, and we're going to do the same as before. You're going to do your git add, git commit, creating the commit ID. And again, SEDATED's not going to fire on the commit, on this commit. It's only going to fire when you try to push it up to the server. So we can go and do add commit. There we go. And now when we do our git push, you're going to see SEDATED fire again. But this time, when it fires, you'll see a much different error message, and you've killed the credential panda. Now he's dead. So you can see in the error message, we're actually showing the developer the commit ID that has, because you can push multiple commit IDs in it. So the commit ID, the file, and then the actual violation itself, we're outputting straight to the developer right away to the console. We show them how many violations, and then clearly a push rejected. And then another handy thing is at the bottom here, you can add in your organization's URL for instructions on exactly how you want the developer to remediate when violations are found. And you can see in the bottom, it took 17 milliseconds for this to run. to run through. And with that, we'll pass it back over to Simeon.
So one thing we wanted to talk about as we're open sourcing this and going through that is how we combine this code that we're showing you with processes. This code on its own will do things, right? And it's going to look for things. But we married this up with some processes that we're going to walk you through that really create an overall robust solution to this problem. You'll see here in a second why this is necessary. So we wanted to talk about those processes with you and explain those. One in particular, the whitelist process. So this is false positives. If you go and you turn this thing on in your organization, it is inevitable that you're going to have false positives. No matter how extensive the regexes are, you're probably going to have instances where it flags one and it's a false positive. So we need to create a way to deal with that. So this is our whitelist flow that we've developed within it. So we want to walk through that. So on the left-hand side here, you have a developer. He's pushing a commit number 1, commit 123. And let's say that that has a false positive in it, something that's sedated, thinks it's a password, but it's not. It's going to get rejected, so number 2, sedated will not allow it to go into the repository. But this is a false positive. So the developer sees this, he sees the error message, and he says, this is not actually a password. This was flagged incorrectly. So the next step is the developer can go, number 3, they can raise a pull request into the whitelist file. So we actually have a whitelist file. It's just a text file. You put the commit ID in there, and you raise this pull request. Now, on the repository, and this is kind of part of the process that we're coupling this with, we have the permissions set up on that repository such that, at least for us at Allstate, the developers themselves do not have write access to this. So they can't whitelist themselves. And that's intentional on our part. So we have the permission set up. They can raise a pull request. They can request this, but only the application security team can actually approve that. So that's number 4. So the developer raises this pull request, and he says, for this commit ID, this is a false positive. Number 4, the security team reviews it and looks at it and checks if they agree that it's a false positive. If we agree that it's a false positive, we go ahead and approve it and merge it. And then immediately after doing that, the developer can go to number 5 and just re-push it again. So they go ahead and they push 1, 2, 3, and immediately SEDATED will see this is a whitelisted commit ID, and it'll go ahead and accept it.
Sweet. Yep. And now we're going to go through a kind of a step-by-step of what this looks like in action. So we're going to pick up where we left off before. We're going to create another file. And this time, we're going to add something that could be a false positive in here. You say password equals password. No quotes. And then we'll save that. We'll jump back into the terminal, and then we will go ahead and do the same thing we did before. We'll do our git add and commit. Run that, get our commit ID. And now when we run the actual git push, it's going to be rejected the same as before. But this time, the developers, he's going to see the exact same message as before. This time the developers can be like, well, wait a minute, this isn't a real hard-coded credential. This is a false positive. They give password as a variable. They see it was rejected. So now what they need to do their pull request, they need to make some sort of documentation that the security team can review, which is what we put into one command, which is kind of a chain of a couple commands. But we do a git format patch, which is going to create a patch.txt file, which will give some context to the lead or whoever's reviewing this pull request. And it's going to also do a push. And then it's going to create, take all that output from the push and put it into a hookout.txt file. So this one command is going to create 2 files for them to include in their pull request so that they can use as documentation. So we're going to go ahead and run this. You'll see the exact same output as before, but this time there were 2 files that were created that they can submit for their documentation. So we'll go ahead and jump into Finder. And you can see There's the hookout file. It's in the desktop directory. So we've created that file with that command, and then we've also created the patch.txt file. And you can point these wherever you want. You can customize the command to do whatever you would like. But it's basically those two files that we use for the documentation. And then we copy the commit ID up there that says in this commit. And then we'll jump into, in this case, GitHub, into our GitHub repo under the commit whitelist file. Then we're going to go ahead and add that commit ID that it shows us that had a violation. You can include in there whatever commit message you want to go with it, saying it's the reason why it's not a hard-coded credential. And then in here, you don't want to commit, don't want to allow them to commit directly to master. So you create a branch, they submit that. And then now, in this portion of it, we'll go ahead and submit our documentation. And then wait for it, and boom, black box of reaction. And then we'll go ahead and add the hookout.txt file as well. Throw that in there and drop it in. So now they've got their documentation to go along with their pull request. They go ahead and create it. And this is where the developer's job stops. And now you would be the AppSec engineer or whoever you want reviewing these pull requests is going to go in and look at these files. This is what was included in the patch.txt file. And this will have a lot more context into exactly what was included in their commits. It'll have the commit ID, the file, the violations, and things of that nature. And then the hookout.txt file is helpful because it will show the AppSec engineer exactly what the developer was seeing in their error message. So there's no miscommunication or developer trying to explain something to the AppSec engineer that is maybe hard for them to verbalize. So if the AppSec engineer reviews it, says it's all good, they can go ahead and merge it. I mean, if not, they can put some comments in there, reject it, what have you. But if it's all good, they'll go ahead and click merge. And then they will add that it's verified, put whatever comments you want them to put in there. They'll merge it, and then as soon as you see the pull request successfully merged and closed, the developer will be able to push their code again. They don't have to do anything additional. They don't have to rewrite anything. They can go ahead and just run their git push command again. And then as soon as they run that, you'll see that their message will be a little bit different, but their push will be accepted. You'll see that it has been whitelisted. You'll see that. Shows the commit ID that was whitelisted, and then, of course, that the push was accepted. So it's that simple. It's pretty straightforward. It's just a standard pull request that an AppSec engineer reviews to get around that. And then Simeon wanted to add something to that.
Yeah, go ahead.
What are you using to detect the credentials? It's just a regex space?
Yeah, we're going to talk about that actually. We're going to show you some of the source code. Yeah, exactly. Just a quick comment on this we wanted to mention, there's always room for improvement. So here in our instructions, we're very clear for us in our instructions linked to the developer. Make sure that this pull request that you're raising is truly a false positive. We don't want them actually taking and generating documentation like this that actually has a password in it, then creating a pull request and attaching a file to that pull request that has a password in it. That's what we're trying to prevent in the first place, right? Now, there's room for growth here. We're working on things like maybe instead of having them attach that file to the pull request, we have them put it on a secure server with very limited access.